In one way, this is a special case because we have a fraction as one of the coefficients. A is equal to 1, B is equal to -3, and C is equal to 9/4. So plugging that in, negative of -3 plus or minus the square root over all of the following. -3 squared minus 4 times 1 times 9/4. All of that, including the -3 and including what's under the square root, all over 2 times 1. The negative of -3 would give us +3, and 2 times 1 would just be 2. Underneath the square root, where our main concentration is, we'd have 9. There's only one minus or one negative here, so we're subtracting. And 4 times 1 is 4, so 4 times 9/4 is going to cancel and give us 9. This is the main reason that this is something special. 9 minus 9, of course, is 0. So we have 3 plus or minus the square root of 0 all over 2, which is defined. Square root of 0 is 0. Whether we subtract 0 from 3 or add 0 to 3, we're getting 3 either way, so we get a single answer that x is equal to 3/2. There are 2 points I want to make. The first one, which is not as important, if you have all your coefficients or a multiple of the same number, you could divide every term on both sides by the same number and get an equivalent equation. An equation, a quadratic equation in this case, with the same solutions. Similarly, in this case, we could multiply everything by 4. And when we see that, what we get, 4 times x squared minus 4 times 3x is 12x, and it's going to cancel here. We still have 4 times 0 equals 0 on the right-hand side. I'm going to do something different with this momentarily, but now we could be plugging in just integers into the quadratic formula. So a equals 4, b equals -12, and c equals 9. It's going to give us that x is equal to the negative of -12 plus or minus -12 squared minus 4 times 4 times 9 all over 2 times 4. Negative of -12 is +12. -12, all of that squared is 144. Still only one minus. 4 times 4 is 16, and 16 times 9 is 144. In the denominator we have 8. Still my main concentration is on what's in the square root. Well, we're still getting 0. Subtract 0 from 12 or add it to 12. We're going to get 12 over 8, and that dividing top and bottom by 4 is still going to give us 3/2. So that was, I think, a minor point that we could get rid of the fraction by multiplying everything by the same thing, all terms on both sides. By the way, if I had multiplied everything here by 2, if we had had the equation starting out this way, you could have divided everything by 2 to get smaller numbers for our coefficients to plug into the quadratic formula. But the main point I want to make, and you may want to refer to my other playlist about completing the square, which includes talking about perfect square trinomials and binomials squared. Once I got rid of the fraction by multiplying everything on both sides by 4, we have here a perfect square trinomial, because you square 2 to get 4, you square 2x, that entire quantity squared is 4x squared, you square 3 to get 9, and besides the 2x and the 3, 2x times 3 is 6x, we double that, we've got 12x. So that fits this formula of a squared minus 2ab plus b squared. That perfect squared trinomial is equal to the quantity a minus b, all of that squared. Therefore, I could have, lining up here, we've got, this is a different use of a and b, by the way, compared to what we've got in the quadratic formula. A is 2x, and b is 3. We could have factored that as the quantity 2x minus 3, that quantity squared equals 0, and applied the square root property, canceling the squaring on the left, not forgetting the plus or minus. 0 has no sign, so 2x equals 3, and x equals 3/2, same solution. So notice how we're only getting a single answer there. When we were using the quadratic formula, whether we started with it this way or this way, when we used the quadratic formula, we wound up with a 0 underneath the square roots, and we only got a single answer. I'm also addressing my other point. I'm hitting 2 or 3 different points here about how we could deal with making the larger numbers smaller or getting rid of fractions. That's a minor thing. I'm also using this to talk about efficiency. The quadratic formula can be used to solve all quadratic equations, but if the directions do not specify that that's what you must use, it's not always the most efficient. I think here, factoring that is going to be a whole heck of a lot quicker. But then a third major point is that when we were using the quadratic formula, we had a 0 under the square root, and we only got a single solution. Also, I want to point out, you only put numbers into the quadratic formula. You don't put anything about x. The whole thing at the beginning of this playlist, showing how the quadratic formula was developed, a, b, and c are just the coefficients.